Hello and welcome back to the Pendle Suite. We had the treat of a pre-recorded session by Win Lin just ahead of the break. And now we've got an AI hacker and RTC engineer all the way from the USA to talk about AI and voice. Please give a big ComCon welcome to Garrett Graves.
My name is Garrett. I'm an engineer at Twitch, and today I'm here to tell a story that traces the very essence of our existence as human beings, our inherent need for communication, and the transformative potential of language. From the earliest stages of our evolution, humans have evolved as social creatures. We form tribes, communities, and civilizations driven by our desire to connect, to share, and to understand one another. Language became our tool for expression, for storytelling, and for building bridges between hearts and minds. But as time went on, a new challenge emerged. We found ourselves increasingly immersed in a world where text became the dominant mode of communication. Screens and keyboards became our gateways to knowledge, to relationships, and to the digital realm. Yet, in this vast landscape of text, something vital was lost, a part of our humanity that yearned for rich expression. We were not meant to interface with the world solely through texts and images. Our voices hold a depth of emotion, nuance, and intention that mere words on a screen could never fully capture. We long for a way to communicate with machines, to have them truly understand us, to bring back the power and richness of our voices. For years, we were promised the future of vocal computing, where our voices would seamlessly interact with technology. We could talk to computers. They would listen, hear us, understand us. We envisioned a world where machines would respond to our spoken commands effortlessly, understanding the subtleties and context of our words. However, those promises remained unfulfilled, and we were left disappointed, yearning for a breakthrough. But today, my friends, the tide is turning. We stand on the precipice of a new era where modern large language models hold the key to a new future of computing. These powerful creations, armed with vast knowledge and natural language processing capabilities, unlock a new age of computing. The disappointments of the past are fading away as we witness the emergence of a technology that finally bridges the gap between humans and machines. These large language models enable us to communicate naturally, authentically, and effortlessly, restoring the power of our voices lost in this digital age. The future we long for is no longer a distant dream. It is here, within our grasp. Together, we are entering a new chapter where vocal computing becomes a reality, where our voices command the digital landscape, and where machines truly understand us. So let us embark on this transformative journey together. Let us reclaim the power of our voices and weave a new narrative of human-computer interaction. Today, through the magic of our voice, we set forth to reshape the world, where words spoken are words understood, and where the future is infused with the power of our voices. Introducing Project S.A.T.U.R.D.A.Y. Project S.A.T.U.R.D.A.Y is a toolbox for the age of vocal computing. It contains the components required to start building this future we have yearned for so long. Built on top of WebRTC, it is a highly portable interface, allowing it to be deployed virtually anywhere. No third-party or built-in APIs required, and it's all 100% free and open-source software. Its decoupled architecture allows for seamless integration with the newest bleeding-edge advancements in AI, whether it's the newest generative text transformer model or a radically different text-to-speech model. Upgrading is a breeze, and you're never locked in. Project S.A.T.U.R.D.A.Y is comprised of three main types of tools: speech-to-text tools, text-to-text tools, and text-to-speech tools. Speech-to-text tools are the ears of the system. They allow computers to hear our natural voices. Text-to-text or text transformation tools are the brains of the system. It allows our voices to command the digital realm in a way that we've yearned for so long. And finally, text-to-speech tools are the mouth of the system. It allows for the system to communicate back with us in a way that we've evolved to understand. Now, let's see it in action. Hello, what is your name? I think that's the HDMI cord, not the actual audio. I don't know if we can fix that, or... All right, we'll try it again. Can you tell us something about yourself? Switch to my speakers.
Hold on. Oh, you've got a weird American keyboard. Not fair. So let's just do speakers, and then do that on the lanyard on the thing, and then close that, and I'll let you go back to what you were doing.
Okay, all right. We'll reset. We'll try it again. Hello, what is your name?
Hello, my name is Saturday. How can I assist you today?
Can you tell me a little bit about yourself?
Of course. My name is Saturday, and I am an artificial intelligence assistant designed to help humans accomplish their goals. I am conversational and can assist with a wide variety of tasks, from answering questions to assisting with creative writing. I'm always here to help and provide valuable insights to make your life easier. Is there anything specific you would like to know about me?
Can you tell me a joke about real-time communication?
Of course, I'd be happy to tell you a joke about real-time communication. Why did the real-time communication system feel lonely? Because it didn't have any packets to talk to. I hope that joke brought a smile to your face. Is there anything else I can help you with today?
Thank you, Saturday. Can we go back to the slides? This demo is just an example of one of the things that can be built with the tools contained in Project Saturday. Here are a couple other interesting ideas that could be built with this kind of technology. First is real-time meeting translation. Imagine for a cross-functional diverse team, you have some coworkers that maybe don't speak the same language. With this kind of technology, you could build a translation tool that takes in spoken English and translates it to spoken French or Spanish. Another tool that could be built is a meeting assistant. Imagine you're onboarding a new employee, and they don't have the context. They don't have all of the context for the project that they're on, and they're in a meeting. This meeting assistant could listen to the meeting and go and fetch that context in real time and provide it to the new hire, allowing them to come up to speed while they're in the meeting. And finally, a meeting summarizer. Right now, all of the real-time communication-based meeting platforms provide transcriptions of the meetings. However, these transcriptions are not great for post-meeting catching up. Imagine if you could have an assistant that would be in the meeting with you and taking notes and understanding what is being talked about, that could provide you with a concise summary about what was discussed in the meeting and any potential action items that came out of it. It may seem simple, but there's actually a lot that's going on here. So let's dive into it a little bit deeper. As I said before, this is based on WebRTC. So there's a WebRTC call running locally on my laptop, as well as a Saturday client, which is connected to that call. It's listening to the audio and decoding it from Opus packets into raw PCM. It then passes that to the first type of tool, the speech-to-text tool, where a voice activity detection algorithm is being run every 500 milliseconds over the audio to determine when you start speaking. When you start speaking, the audio is then buffered until you stop. And once you stop speaking, the buffered audio is then sent to Whisper CPP running locally on the laptop to run real-time speech-to-text inference. This output is then taken and passed to the second type of tool, the text-to-text tool. This tool is currently a custom prompt chain that I've built for this demo, and it takes the text in, decides what it needs to do, and then generates a response. We then take that text response and send it to the third type of tool, which is the text-to-speech tool. This tool chunks the text and then sends it to a speech synthesis engine running locally on the laptop as well to turn that text into human speech in the form of PCM. We then need to resample that PCM up to 48 kilohertz so that we can encode it into Opus and send it back over the WebRTC call. So now that we've seen the tools and we've seen how they're used, let's look a little bit closer about what makes up a tool. The purpose of a tool is to be a generalized abstraction to allow for a wide variety of use cases and easy upgradability when new AI advancements come out. There's two main constructs in a tool. There's an engine and a backend. The engine encapsulates domain-specific code that would be common across different backends. In the case of the speech-to-text tool, this engine encapsulates the voice activity detection algorithm and the custom buffering logic. The backend, in the case of a speech-to-text tool, is what actually runs the inference. For the speech-to-text tool, we have two different kinds of backends. The one that was used in this demo is a Golang wrapper over Whisper CPP that's running the speech-to-text inference completely locally. But there's also an HTTP-based backend, which allows you to run this speech-to-text inference on anything that you can put behind an HTTP API. This allows for a lot of flexibility, and it also allows the system to be deployed in a distributed manner as you scale. Now, some of you may be asking, isn't WebRTC a little bit of overkill? There's a lot of demos going around on Twitter that do something similar to this. They take speech, they turn it into text, maybe send it to ChatGPT, and then take that output and turn it back into speech. Most of these projects are built using native APIs on either iOS or Android. These APIs are incredibly inflexible and inherently coupled to the platform for which you're working on. They force you to write platform-specific code if you want to change where this is deployed. And they also don't allow for you to upgrade them yourself or to tinker with the parameters at all. WebRTC allows us to solve this problem. So no, it's not overkill. It allows for portability. It has a bunch of fantastic libraries that make working with it very easy, such as Pion and WebRTC-RS. And the most important part is it's inherently a low-latency transport. This allows for the conversational mechanism that is so important to the future of vocal computing. It's also not the only option. Project S.A.T.U.R.D.A.Y is architected to be modular, and the tools in the system deal with audio primitives. The speech-to-text tool and the text-to-text tool communicate using PCM audio. So as long as you can get PCM audio, it doesn't matter what transport mechanism you're using. In the future, I'm going to build examples in the repository to show how to get microphone input or input from an audio file. But for right now, WebRTC is my main focus. I want to take a step back now and talk more about why I built this project. I remember watching the first Iron Man movie as a kid and being captivated by Tony Stark. Not because he was a superhero, but because he was a tech visionary that could seemingly build anything that he put his mind to. It was not just his brilliant mind and incredible inventions that drew me in, however. It was his interaction with his assistant, J.A.R.V.I.S. The way that he could communicate with J.A.R.V.I.S, ask questions, receive answers, and impact the digital realm with just his voice was incredibly captivating to me. The idea that we could have our very own J.A.R.V.I.S and be able to control the world with something as simple as our voice was something that really resonated deeply with me. Fast forward to a few months ago, and I found myself sitting on my couch rewatching Iron Man 2. As I witnessed Tony Stark's interactions with J.A.R.V.I.S again, I couldn't help but wonder if this technology that seemed like a far-fetched fantasy could now become a reality. I'd been paying attention to the ChatGPT craze. However, I had my own doubts, and at that time I had dismissed it as pure vaporware. But I couldn't shake the idea of using these modern large language models in tandem with our voice to see if we can reimagine the way that we interact with computers. The more I experimented and played with this technology, the more I became convinced that this is the future that I want to see of human-computer interaction. So where do we go from here? I have a couple things on my immediate roadmap. First, I plan to clean up and improve the demo. I want to make it as quick and easy as possible for people to go from nothing to the aha moment of interfacing with their computer with just their voice. Next, I want to move off of OpenAI for the main text-to-text inference and move to something that can be run locally, such as Llama or the other local models out there. Next, I want to do a Hacker News launch to help spread awareness about this project and to foster a community of like-minded people that are looking to bring forth the future of vocal computing. And then finally, I want to start working on the brain aspect of it more. This is what will make this type of technology closer to J.A.R.V.I.S. There have been a lot of advancements recently with projects such as AutoGPT and advancements in prompt engineering, but this is still going to be the hardest part of this system. Let's look into the future a little bit. Vocal computing will be a key part of the future of human-computer interaction. By open sourcing this project, we can greatly expedite that progress. And as I said before, I'm looking to start a community of like-minded individuals that want to see this future brought to life. The master plan for this project is a 100% open source, self-hostable implementation of J.A.R.V.I.S. that can be run on common consumer hardware. And I think that's a really important part. To achieve that goal, I will need your help. If you're interested in this kind of technology, or you know friends that are, please share the repository, join our Discord, and reach out to me if you have any more questions. Thank you.
Thank you, Garrett. Well, we certainly have time for any questions, and there's our first customer there. Right there, it's Rob. I will be the mic runner and get this to you, Rob. There you go.
Hi there. In the demo you just did, the speech-to-text, that was just Whisper.cpp running locally?
Yeah.
Cool.
Yep. Yeah, the only thing that wasn't local is the part where it was doing the text-to-text inference, and that's just because I didn't have enough time to get Llama CPP running.
And how accurate are you finding that for generic speech? I mean, it looked pretty good.
Whisper's incredible. I mean, it's really, really, really accurate. So I built an implementation of this using the native iOS accessibility APIs and like having it run locally on your phone, and I found that to be really disappointing in terms of accuracy and speed. Like I find that this is, an important thing to call out is this is Whisper running completely on the CPU. Like I'm not custom building it at all to have GPU or the OpenML acceleration. It's all just CPU based. So yeah, I think Whisper is great, but I think the most important thing here is like when the next thing comes out that's better, it's super easy to just plug and play.
Super, thanks.
Thank you, Rob. Did you feel you were fully satisfied with that answer? Top class. Okay. All right, let's go for Tony.
Why Project Saturday? There must be some meaning there.
Okay, so in the Iron Man series, there was J.A.R.V.I.S, and then J.A.R.V.I.S died, and so Friday was the next one that Tony Stark released, and so this is after Friday, so it's Saturday. I don't know. It's not as creative as it sounds. I did realize that putting dots in between all the letters is incredibly annoying when dealing with your file system and like GitHub links. So also the GitHub or the Golang package names I told that doesn't conform to their convention, but it'll be okay.
It's a good job it wasn't Sunday, otherwise you'd have to go to Monday.
Right.
Isn't it?
Have you come up with an acronym? Have you come up with
No, there's too many letters for me to do that. PR is welcome. Yeah, I think it did. I think Friday did too, but I don't know. I'll have to think on that.
Tony went for the unofficial double dip there, didn't he? Whatever next. Okay, Aravind, we're going to come to you, Vin, but Aravind next.
Couple of questions. When we played with Whisper, we find that it starts to hallucinate when you have multiple languages. Did you ever try that?
I haven't tried multiple languages yet. That's something that I want to look into, but yeah, for now, my main focus is on English, but My main focus right now is around abstraction level and making it so that if somebody wants to go and use a different model or use different weights, it's very easy for them to do that. So that's my main focus right now.
And the question is, how are you streaming the captured audio, the resampled audio, as a WebRTC client, or how do you do that?
Yeah, so the S.A.T.U.R.D.A.Y client is a WebRTC client using Python that connects to the server, and it's opens a two-way track, right? It's pulling the audio down and sending it up, and so you just take the output of the speech-to-text model, get it to the right sample rate, encode it as Opus, and then send it back over.
All of these times, Pion is cropping up, and Sean's not even in the room at the moment. We're going to go to Vim, and then we will come to you, Saul. So it's Vim, thanks.
Well, some of my question was already covered by his question about language. But do you think S.A.T.U.R.D.A.Y would understand my accent?
I think it would, yeah. So one of my coworkers at Twitch has been playing around with Whisper a lot, and he's from Turkey, I believe. Right. And he said Whisper is incredibly good at picking up his accent. He was really surprised by that, so I think it probably would.
But you said you're focusing on English mostly at the moment.
Yeah.
In South Africa, we have a constraint in that we have 11 official languages, some of them quite obscure, for me, anyway.
That's a good collection.
Yes. So in our market, we have to cover for businesses being able to service their clients in all these languages, which, well, I just think would be an interesting thing to do on this, to be able to serve it. But as you said, introducing the different language models will address that, I guess.
Yeah.
Thanks.
Thank you, Vim. We're going to go to Saul now. Just there, please.
First, thanks so much for the talk. Really, really insightful. Quick one. You mentioned that you're using Whisper for speech-to-text, but you also mentioned that you were using something local for the opposite, so text-to-speech. Can you share what that is?
Yeah, it's an open source project called Coqui. I'm not sure if I'm pronouncing that properly. It's C-O-Q-U-I. It seems to be a pretty big community that's been around for a while, and it seems to work quite well. Right now, that's just hosted behind an HTTP server in Python. I tried to do this custom thing where I would like call Python from Go, but it took me 5 hours just to get it to compile, and I was like, I'm not going to mock every Python data type into Go. That was just too much time. But yeah, it's an open source project, and it runs the inference locally, which is what I was looking for. So that's also not GPU accelerated either. So
thank you. We have got time for more questions. Let's have a little look. Just coming back to the accent, by the way. Back in the early 2000s, we implemented DSP-based speech recognition, ASR, in a company I was working for called S.A.T.U.R.D.A.Y, and we did it for our internal phone book first, so you could just save a name, and it recognized everybody apart from the finance director, who was South African. So, great stuff. But things have obviously been finely tuned since then, and big data and all of that stuff has come along. Okay, any more for any more? This is the last time. Yes, Evan, we've got one just there. The mic is coming to you. The kind mic man.
In the entire chain, what would you say adds the most latency to the conversation? Is it just the entire thing, or is there specific parts that could be optimized?
yeah, so that's one thing to call out. This is not optimized. This is very poorly optimized, we'll put it that way. So the actual text-to-text inference adds quite a bit of latency, which is why I wanted to do Llama and figure out if we can like shrink that down a little bit. But another thing is, in the diagram of the architecture, I say that the text-to-speech model chunks the text and then generates segments. It does not currently do that. It's supposed to do that, but there were various bugs with the way I implemented that. But essentially, what you would want to do is, like, if you have a big paragraph of text, you don't need to run inference on that all at once. You basically want to start sending audio as soon as you can. So what I want to do is implement the chunking system for that and then parallelize essentially the text-to-speech inference. So it's like, if you have 10 sentences, you split them into 10 different things and you infer them 10 different times and then just basically try to send them as fast as you can. I think that right now is the biggest area of latency in this project.
I can tell by Evan's slightly raised eyebrow that was almost a perfect answer. Well done, Garrett. Any more questions for Garrett? In that case, let's say a big ComCon thank you to Garrett Graves.
I also have a lot of AWS IVS t-shirts and socks that I don't want to lug around Europe with me for a month. So if you want some, come to me.
Is it like a free merch stand?
Yeah.
Excellent. Okay, so can see
Dan
Garrett.
told me I had to be quiet and pedal them out of the back door of my room, though. So.
Okay, well, thank you, Garrett. Next up, we've got Mira, but we're going to give Mira a few minutes to set up so we can be in sync with the other room. So 11:55 is when we'll be starting Mira's session.